Earth's climate is very near a tipping point that will mark one of the greatest transitions in human history. We are very close to the warming of the Arctic, releasing large amounts of the two greenhouse gases, carbon dioxide, or CO2, and methane CH4 stored there. If our activities have triggered the release of enough of these gases, then they will farther heat the Arctic, releasing even more gas. Once this process is started, we will not have the power to stop it. If it goes to completion over hundreds of years, then the Earth's climate may shift to the very common hothouse Earth. Should this happen, we will have to redesign all of human society for the new climate. This transition will be difficult but not impossible. The summer of 2019 has been a particularly hot one in the Arctic. Human activity has driven the carbon dioxide in the atmosphere from 300 to 412 parts per million. This has warmed the atmosphere enough to melt a lot of sea ice. Then more open water adsorbs more sunlight, called a blue ocean event. This extra heat melts more sea ice in a positive feedback loop. This is why the Arctic is warming up so much faster than mid-latitudes. The summer of 2016 was a bad year too, one of a few scattered bad years this century. Will these bad years become the norm? The tipping point will come when the greenhouse gas cooked out in an average hot summer exceeds what we can reduce from average human activity. At that point, we no longer have a way to control the situation. The IPCC report estimated that we have until 2030 to address this problem. However, the IPCC report did not include detailed studies of the release of stored methane simply because no scientific papers were available at the time. Do we have that much time left? An enormous amount of methane and carbon dioxide has been in storage in the Arctic since the last full ice age. 3 storage areas exist that can shrink in unusually hot summers. They are, 1. Permafrost, 2. Peat, and 3. Methane hydrate. The permafrost is permanently frozen ground covered by a layer of seasonally thawing soil. This ground structure includes large amounts of organic material that have been fixed for many thousands of years by the cold. When permafrost melts, it first forms pools of water, then the organic matter in the bottom sediments can be broken down by bacteria. This generates bubbles of methane. In many areas, organic matter forms a thick surface layer called peat. In severe hot weather, the peat can dry out and then be ignited by lightning. Such fires burn until the seasons change while quickly releasing vast amounts of CO2. Large amounts of methane are also presently stored in the form of methane hydrate, an ice that forms at the bottom of the ocean. As the sea ice melts, more summer sun can directly warm the water. This warmth then melts the methane hydrate and releases the gas. In deep waters, much of the methane dissolves before it reaches the surface. Large areas of the Arctic Ocean are quite shallow. Their released methane can reach the atmosphere. Currently, we simply do not have enough reliable data to model this complex methane release. Before the ice ages started, the Earth was in the hothouse mode for millions of years. If we cross the methane tipping point, the Earth may return to its familiar hothouse mode. The Earth will be fine. Life will be fine. The open question then is the future of human civilization. For now, we need to watch this tipping point very carefully while making a practical plan for a quality human civilization on a hothouse Earth. Wish us luck. Our little group, the Big Moon Dig, is working on innovative ideas for a grassroots space program and on efforts to aid young people in finding their life's work that will help address our climate crisis. We have a new book out which uses short stories as an educational aid, and we have written a TV or web production screenplay. Summer is coming. Please contact us if you are interested in any of these projects or have ideas on a society for a sustainable hothouse Earth.